In this video, we are going to go over how to graph linear inequalities in the form of x equals a number or y equals a number. In other words, we're going to have vertical line boundaries and horizontal line boundaries. And if it sounds terrible, it just looks a little weird, but it's something that you can totally rock with no problem. So without further ado, the first half of the video will deal with a vertical line problem. The second half will deal with a horizontal. Let's jump into it. So you were told to graph x is greater than 2. Now normally in a single dimension, x is greater than 2 is not a problem. You got your horizontal line. You've got the value of 2 that you put on the number line. And then you do an open circle because we don't include 2 and shade to the right. All right, well here we're asked to do it on the coordinate plane. Well, it's no different than saying that my boundary is x equals 2. And notice that the greater than sign means that we do not include 2, so when we're graphing in 2 dimensions, we use a dotted line. So x equals 2 is a vertical line. If you've forgotten that, there are previous videos that go over why that is. So my boundary is a vertical line at x equals 2. X is 2. So I put a dotted line all along x equals 2, like this. And hopefully I can actually hit x equals 2 every single time, just like that, and make it a little thicker. Beautiful. That's our boundary. And I'll put arrows so that we know that this goes on and on forever. The question is, how do we shade? So it's dotted because we're not equal to 2, but how do we shade? Because in the previous videos with linear inequalities, we've gone over how we go above certain lines or below it. Well, x is only left or right. So you're saying all values to the right of 2, more than 2. Well, on the graph, that would be all values to the right of 2. So you would shade in all of these numbers. And you might say, Mr. Groden, I don't know that I'll remember that. That's fine. If you're one of those students that likes to use test points, let's do that. A test point, perfect one, that's not on the line is 0, 0. So I'll write down test point, and we're going to test 0, 0, and plug those points into the inequality. There's no y value, so you would only plug the x value into it. So is 0 greater than 2? No, 0 is not greater than 2, which means that we do not shade the part of this graph that has 0, 0 in it. We shade the other part, which is this side right here. On the other side of the video, what to do when we have a horizontal line as a boundary. You'll rock it. And here we are on the other side of the video, about to go over, as promised, how to graph a linear inequality that involves a horizontal line boundary. Let's check it out. So we are told that we need to graph y is less than or equal to -1. Now before we got into the whole two-dimensional coordinate plane over here, we were graphing things, as I've shown you in previous videos, I'll show again, on single-dimensional number lines going in one direction. So in this case, you've got a variable is less than or equal to -1. Throw down a -1, you had a closed circle because you were including -1 and you shaded everything to the left. All right, well now we've got a two-dimensional coordinate plane, so our boundary isn't just a single place. Our boundary is the line y equals -1. Notice that we have or equal to, which means that we are going to include our boundary, all y values less than or equal to -1, so we'll have a solid line for our boundary. Now, y equals any number is a horizontal line. We're saying y is -1. That again is in previous videos with how to graph vertical and horizontal lines. So we'll graph out the line y equals -1. It will be solid. Here we go. Here's -1, horizontal line all the way across there with an arrow and all the way across here. Beautiful. That's our boundary. Now we need to determine on what side of that boundary, up or down, we are going to graph. Well, or shade. If we want all y values less than or equal to -1, that's like saying all y values that are below -1 or equal to it. Below that boundary would be all of these values. And I don't shade in heavily, I just draw these lines, but really I'm filling in this whole space because all of these points are solutions. If you are a test pointer, a great test point, if it's not on the boundary, is 0, 0, and it's not on the boundary. Let's use it. So you could also do that test point, and it doesn't always have to be 0, 0. It can be any point as long as it's not on the line itself. So our test point of 0, 0, there is no x value in our inequality, just y. So we'll input y is 0 is less than or equal to -1. Is 0 less than or equal to -1? No, it's not. So that means that 0, 0, and all the points in that part, in that half plane, are not solutions to the inequality. So we would shade in all the points on the other side of the boundary, which we already did using the other logic skills. That's it, peeps. How to graph linear inequalities when there's horizontal lines or vertical lines of your boundaries. Not so bad. Go rock some practice.